Welcome back to repairing and rewiring lighting. Last time we left off, last time we left off, I was having a very difficult time figuring out how to get the base, the metal base of this socket removed from the shade. And so one of the things I can tell you is that if you understand what the parts of the whole are, it's easier to take things apart. And the fact that I had a basic understanding of a few different ways that the connection between these two parts might have been made really made it possible for me to figure out a way to remove that part. So it's also very helpful to have the right tools and to be patient, and it may well require sometimes to think creatively about how to solve that problem, but also doing some research, going online and reading a little bit about this, or going and watching other instructional videos about how other people have approached this problem would also be very useful. So anyway, after soaking these parts in penetrating fluid, I was able to get them to come apart. And this is where, patience really paid off. After 24 hours of it soaking, I tried and I unsuccessfully to get those parts to budge. But what I was able to do after cleaning it up and fooling around a little bit is to get a better look at what that connection was like. So after the first 24 hours of treating it with that rust-busting, penetrating fluid, I was able to actually see that there was a threaded nipple that was making the connection between this part and this part here. And they had thoroughly fused together, most likely because they were made out of different materials. And if you watch the Fascination demo, you learned a little bit about how when dissimilar materials are connected with each other, especially under damp conditions, that it can precipitate a kind of exchange of molecules that aggressively corrodes those parts and pieces, so they just eat each other up and end up fusing together. So another 24 hours of thoroughly soaking and a little bit of MacGyvering a couple of tools together to get those parts to move out, and we're moving forward. So I'll drop in some pictures of the way that I was able to do this, but basically I needed to be able to hold on to this from the inside of the form and then secure this or rotate this part. So the rig I came up with was to take a pair of fine needle nose pliers and use those like a spanner wrench to reach through those two holes, and then to use this adjustable wrench to be able to hold on to this, and that allowed me to be able to rotate that guy out. So, sometimes we have to adapt different tools to different problems as those problems present themselves. Anyway, so good news is that I got this off, right? Bad news is that this is, this is a threaded nipple, and we'll talk a little bit more about threaded nipples in a minute, but they come in different sizes. And so the first challenge I came up against is I wanted to replace my socket with a porcelain socket to try to be as consistent as possible with both the aesthetics and the kind of function of this. So the only thing that I can find available was this guy, which had a 1/4 inch and not an 1/8 inch threaded component to receive that nipple, but it had the type of studs that I wanted to be able to wire directly to that. And I liked that because it's a very confined space. There's not a lot of room to have wire nuts or to even have butt splices in a space like that. So I really liked this, but I didn't like the fact that I didn't have that transition. Now, I could have gotten a transitional coupling, or what's called a reducing coupling, that would go from 1/8 inch to 1/4 inch. But I went to another hardware store and I found one that did have an 1/8 inch base on it, but it had these 2 lead wires that were fixed in place. And again, I don't have enough room in there to accommodate a butt splice or wire nuts to use something like this. So I'm looking at this yesterday and I'm thinking, you know, how can I get this on this? So upon closer examination, I can see that there's actually just a single screw that holds that in place. So what I'm hoping we're going to be able to do is to take those 2 parts and swap them out. So let's see if we got lucky there. So let's take a little bit of a step back and go through some of the parts and pieces that we've got together for this project. So I have the fixture sockets, which we just talked about. And I also picked up a few examples of different types of switches that we could look at, so that, you know, again, this was originally meant to be wired, what we call hardwired, which meant that it was actually wired into an electrical box on the wall, and that it would have been connected to a wall-mounted switch. But I wanted to also show you that, you know, if your socket does not come with switching like this pull chain switch that allows us to turn this on and off, or if it doesn't have a rotary switch, then we can have what's called an inline switch like this that can just get mounted on one of the 2 wires, and the second wire would pass behind it in parallel, and we'll open that up and look at it. We could possibly use something like a rotary switch like this, or I opened this guy up so you can see another example of just exactly how that switch works to open and close those positions, to energize it or to de-energize it. Now, inline switches, rotary switches, you know, great for little lamps and stuff, but for this wall sconce, we're probably going to have to figure out something else, because there's just not any room in here to accommodate those switches in a way that is aesthetically consistent with the lamp, and that would also, you know, give us that ease of function. So I talked about threaded nipples. You can buy threaded nipples in different lengths. Those can be cut down to size. Those threaded nipples go by a standard that is called IPS, or we talked about NPT, or National Pipe Thread, which is a tapered thread, because when you're transferring fluids or gases through pipes, you need to have a liquid or gas type seal. But for things like lamp applications, we're going to use what's called IPS, which is the same standard or frequency of occurrence of threads as NPT, but it has parallel sides instead of being tapered, because we're not trying to make an airtight fit with this. So I can use an 1/8 inch NPT tap for creating internal threads on an IPS thread, or those parallel threads. So, and the other thing that's really useful about these taps is that if I had a part like this that I needed to clean up, because let's say that I ended up having to drill this nipple out because it was so corroded, I can actually come back in and use a tap like this to clean those threads back up, right? So threaded nipples can also be used along with couplings. Couplings have two female ends so that we're able to screw one on the end and then mate another nipple to that to extend the length of it. And that's probably what we're going to have to do here, because I think the likelihood of me getting this little short nipple out of there is, it could be done, but I just don't know that it's worth the effort. I think instead what we'll do is we'll try to put a coupling on there and just extend it out slightly. So we have threaded nipples, couplings. There are also nuts and washer sets that come along that you can find in most lighting sections of a hardware store. They have these lamp repair parts. We're also going to try and use a decorative lamp cord that has a cloth covering on the outside of it. We're replacing this 18 gauge 2-wire with a cloth covered cord, because I just think it'll look better. But we might have challenges in terms of being able to fit it through or feed it through these existing holes. We'll see as we go along. These cords typically come with a plug attached to the end of them, and you could either use that plug, or we could replace it with a different style of plug that might be more aesthetically consistent with that object if we're putting a plug on the end of that. So we're going to look at these different plugs and talk about in detail how they're used and what makes them different. And what else? Oh, we're also going to look at little end caps that can be used for as a decorative finish on that for wall mounting things like sconces. And these brackets, which are used to mount to the octagonal boxes in the wall itself. So inside of our wall, and we'll hopefully get some detailed shots of this, inside of our wall is that octagonal box mounted flush with the wall surface. This plate screws down to it. The nipple extends out of it. Then our nipple extends out the end of our piece just enough to get a decorative nut on there, and that secures it in place on the wall. So if we have enough time, we'll do a little demo of actually how to hardwire a sconce like this in place. When I'm when I'm sort of trying to come up with a shopping list or a needs list for any project that I'm working on, I like to go ahead and write out the list and do a little drawing that shows details of where those parts are going, so that when I go to the hardware store, or if I go to my online to buy parts and pieces, I can see where that piece is being used and the correspondence between the other pieces, so that if I come up against a situation where I can't find exactly what I need, having that visual might help me problem solve what the correspondence will be between those. Do I need a transitional coupling to go from one size to another? What are my existing parts and pieces? Because I just can't rely on my memory for those things. So I like to take little notes, and if it's to the hardware store I go, I also I often I took this lamp base with me so that I could compare it to the lamp bases that were available and make sure, and here I'm using vernier calipers, I could make sure that it was going to fit inside of that space. So I think it's probably time to move in for a closer view and see some of the details of what's going on this table.